Was Oumuamua an alien ship? Everything we know so far.
Now, this discovery was important for many reasons, but to me the most significant is for what Oumuamua can tell us about the past of our solar system.
In 2017, a peculiar object raced through our solar system at astonishing speeds. Named Oumuamua, it became the first interstellar object ever detected by humans. However, by the time we identified its presence, it was already leaving our vicinity. Due to limited observations, we still don't know exactly what it is or where it originated. What truly makes Oumuamua remarkable isn't just its interstellar nature, but the baffling behaviour it exhibited. Its actions were so unusual and seemingly contradictory to the laws of physics that some scientists have speculated it could be explained by alien technology. So, what exactly is Oumuamua? Was it a strange natural phenomenon, or a piece of alien technology, sailing silently through space? If you're fascinated by mysteries like this, make sure to subscribe to UFO Universe for more deep dives into the unexplained. Hit that bell icon so you never miss a journey beyond the stars. As scientists delved deeper into the enigmatic object, the mystery only grew. They found that before it was detected, while still beyond the range of our instruments, it had travelled alarmingly close to the Sun, skimming within just 23 million miles of its surface, closer than Mercury's orbit. Then, something extraordinary occurred. The object abruptly accelerated by nearly 3.5 times its previous speed. It surged to an astonishing velocity of 194,500 miles per hour, or 55 miles per second, as if propelled by an unknown and powerful force.
Now, Oumuamua was moving away and fading very rapidly. In the span of about a week, it had dropped in brightness by a factor of 100.
The enigmatic interstellar object was named Oumuamua, a Hawaiian term meaning scout or messenger arriving first from afar. However, its true nature remained elusive. By the time it was discovered, it was already speeding away from Earth. Currently, Oumuamua is over 4.3 billion miles away, exiting the solar system. Based on its trajectory and velocity, it is unlikely to ever return to our vicinity. Its peculiar shape, absence of a gas tail, and, most notably, its origin from interstellar space left scientists puzzled. Increasingly, researchers began to consider the possibility that Oumuamua might not be a typical celestial object, but rather an artificial spacecraft, potentially sent by an intelligent extraterrestrial civilization. To explore this bold idea, a large-scale initiative called Project Lyra was proposed. The mission aimed to send a probe to intercept Oumuamua, examine it up close, and finally determine its true nature. Following the discovery of Oumuamua, the scientific community was swept up in a surge of excitement. This mysterious object defied classification, leaving experts baffled about what exactly it was. It posed a challenge to everything previously understood about space. Astronomers worldwide quickly redirected their telescopes and abandoned their own research projects in a race to gather more data before the object disappeared forever into the vast darkness of interstellar space. Initial observations estimated Oumuamua to be approximately 1,300 feet long and only 130 feet wide, giving it a peculiar, elongated, cigar-like appearance that was unlike any known celestial body. However, with new data, scientists from McMaster University in Canada recalculated its dimensions, suggesting it might have been around 380 feet long, 364 feet wide, and 62 feet thick, slightly larger than the Statue of Liberty. This revised analysis indicated a flatter, pancake-like shape, which is also highly unusual for space objects. While similar proportions have been observed in rare cases, such as Arakoth in the Kuiper Belt beyond Neptune, these exceptions do little to diminish Oumuamua's enigma. Its atypical shape continues to intrigue and puzzle scientists. We're witnessing something extraordinary and enigmatic an object racing through space at an astonishing speed of 16 miles per second. To put this into perspective, it's even faster than Voyager 1, one of the quickest spacecraft ever launched by humanity. At such a velocity, Oumuamua could travel the distance between New York and San Francisco in just 2 minutes and 38 seconds. This incredible speed suggested that the object was not under the sun's gravitational influence, a theory that was soon confirmed. It turned out to be a distant interstellar visitor, but where had it originated from? And more intriguingly, what exactly was it? Astronomers initially anticipated spotting a bright tail of gas and dust as they observed the rapidly retreating object. They had assumed it was a comet, which typically behaves predictably when nearing the sun. Solar heat causes ice and frozen gases on a comet's surface to evaporate, releasing dust and gas into space. These emissions create a glowing tail trailing behind the nucleus, reflecting sunlight. A striking example is Comet Hale-Bopp, whose tail was visible to the naked eye from Earth in 1997. However, Oumuamua defied every expectation. As it passed the sun, there was no sign of evaporation, no dust, no gas, not even the slightest indication of a tail. Its behavior contradicted all the established rules for typical comets. This enigmatic visitor left scientists puzzled. Its unusual shape, peculiar trajectory, and astonishing speed all suggested one thing: this was an entirely unique object, unlike anything humanity had ever encountered. The scientific community remained gripped by growing intrigue and tension. The central question was this: is Oumuamua merely a typical cosmic object, or could it represent our first encounter with extraterrestrial technology? Yet, the most puzzling aspect was still to unfold. Oumuamua exhibited an unexpected acceleration, one that seemed inexplicable, as though it were operating under its own design. Scientists discovered that 40 days prior to its detection, the object had passed alarmingly close to the Sun, skimming just 23 million miles from its surface. It was after this close encounter that it mysteriously gained speed. At its maximum, Oumuamua reached a velocity of 54 miles per second, which was 3.5 times faster than its speed before approaching the Sun. This extraordinary speed is remarkable, 5 times faster than Voyager 1's current pace, 11 times faster than the Starship rocket, and 250 times the speed of sound. Such acceleration is usually associated with comets, where jets of dust and water vapor from their tails provide an extra push. However, as previously noted, Oumuamua displayed no evidence of such activity. So, what caused its sudden acceleration? So, could Oumuamua be a spaceship? What if this mysterious object wasn't just a piece of space, ice, or rock? Imagine that 8 years ago, something far more extraordinary, perhaps a spacecraft engineered by an advanced civilization, passed near Earth. This idea was proposed in 2021 by astronomer Avi Loeb, then the head of Harvard University's astronomy department, alongside his colleague Shmuel Bialy. They suggested that the first interstellar object ever detected might actually have been an alien space probe. Scientists believe that Oumuamua's unusual behavior provides ample reason to suspect it might be something truly unconventional. What captured scientists' attention most was when the object unexpectedly accelerated as it passed by the Sun. While the Sun's gravity could have propelled it, calculations indicated that this acceleration should have been much weaker. This led Avi and Shmuel to propose an intriguing hypothesis. What if this wasn't merely a rock from another star system, but an object utilizing light sail technology? At first, the idea seems extraordinary, yet it's grounded in real physics. A light sail is a thin, lightweight structure that can move using the pressure of light. Streams of photons from the Sun, for instance, exert a small but constant pressure on the sail's surface, gradually accelerating it to high speeds without fuel. If Oumuamua had such an ultra-thin structure capable of harnessing solar radiation pressure, the solar wind could have provided the additional thrust. Their calculations suggest that for this to be feasible, the sail's thickness would need to be between 0.3 and 0.9 millimeters, comparable to the thickness of a human hair. Imagine an object 380 feet long and less than a millimeter thick. While this may sound wildly improbable, light sail technology already exists. For instance, the Japanese spacecraft Ikaros successfully demonstrated this concept in 2010, becoming the first probe to utilize solar radiation as a propulsion source during its mission to Venus. Maybe Oumuamua was something similar, an object outfitted with a solar sail, designed to accelerate and alter its trajectory as it traveled past star systems. If it were indeed an artificially constructed device, it's plausible that, aside from the sail, it also contained additional technological components, though these remain purely speculative at this point. However, one thing seems evident: such an object would likely require at least a system for scanning its environment and a means of communication to send data or receive signals from its creators. Shmuel Bialy and Avi Loeb conducted calculations to assess whether Oumuamua's light sail could endure an extended interstellar journey. They analysed the density of interstellar gas and dust, along with the speed at which the object would encounter these particles in space. The findings were remarkable. If Oumuamua were indeed a device of this nature, it could have travelled at least 16,000 light-years from its origin star system while remaining intact. However, the scientists do not assert definitively that Oumuamua is a spacecraft. They simply propose that the possibility exists and argue that it is significant enough to warrant consideration in scientific discussions. If Oumuamua were truly an artificial object, a solar sail is just one potential explanation. It could have been a far more sophisticated and advanced probe, perhaps an active unmanned spacecraft sent to explore our solar system. There are also reasons to believe it wasn't carrying any life. For instance, Oumuamua's velocity suggests it could travel 1 light-year in approximately 11 to 11.5 thousand years. Given that the nearest star, Proxima Centauri, is just over 4 light-years away, the journey would have taken Oumuamua around 44 to 46,000 years. Such lengthy trips would be unfeasible for living organisms, indicating that if it were a spacecraft, it was likely operated remotely, either by an automated program or controlled from a distant source. Nevertheless, not everyone agrees with this perspective. Numerous scientists view the notion of a potential spacecraft or artificial object as highly speculative. They argue that there is insufficient direct evidence to substantiate such ambitious assertions. Scientists Alan Jackson and Steve Desch from Arizona State University have proposed an alternative hypothesis regarding the nature of Oumuamua. They theorize that it might be a fragment of frozen nitrogen, a substance found on celestial bodies like Pluto. For instance, when the New Horizons spacecraft passed by the dwarf planet in 2015, it observed icy plains such as Sputnik Planitia, expansive regions of frozen nitrogen. The researchers suggest that a significant impact could have dislodged a piece of such a surface from a Pluto-like planet, sending it on an interstellar voyage. As it neared the Sun, the heat likely caused the nitrogen to evaporate, producing a jet-like propulsion that could account for the object's unexpected acceleration. In the meantime, scientists Darrell Seligman from Cornell University and Jennifer Bergner from the University of California, Berkeley, have proposed their own theory regarding this enigmatic object. They suggest that Oumuamua was originally a typical water-rich comet orbiting a distant star. However, it was eventually expelled into interstellar space. During its extensive journey across the galaxy, it encountered intense cosmic rays, such as those from supernova explosions. These rays may have converted up to 1/3 of the water ice into hydrogen molecules, which became trapped within the ice. When Oumuamua approached our Sunday, it heated up, causing the accumulated hydrogen to escape in small jet-like streams. This escape provided the object with an extra boost. The absence of a bright tail typical of comets, can be attributed to the fact that lightweight hydrogen lacks the force needed to carry significant amounts of dust. Consequently, this led to noticeable acceleration without any visible trail of dust or gas. Other researchers propose similar explanations for this mysterious object, while some suggest even simpler theories. Karen Meach, an astronomer at the University of Hawaii at Manoa, posits that Oumuamua might just be an ordinary comet with an unusually low dust content, which would explain the lack of a tail and its peculiar shape. Perhaps such objects are not as rare as they seem. Their apparent uniqueness could simply reflect our limited observational experience. The universe is filled with an incredible variety of shapes and structures, and cigar-shaped or disc-like objects may be far more common than we currently realize. Most of them are likely too distant for us to detect. While most scientists believe Oumuamua is probably an asteroid or an unusually shaped comet, there's still no conclusive proof, leaving the fundamental mystery unresolved. How can we ever be certain what this strange interstellar object truly was? Pursuing it directly is a daunting challenge. Due to its immense distance and small size, even the most advanced space telescopes can no longer detect it. Trying to observe Oumuamua now would be like attempting to spot the city of Sydney from the coast of San Francisco using basic binoculars. Virtually impossible. In fact, only the Hubble Space Telescope managed to track it for a brief period before it disappeared completely into the depths of space. However, what if we attempted to catch up to this object and study it up close? While the idea seems daring and nearly unattainable, it's precisely the challenge that scientists have embraced. Just 11 days after Oumuamua's discovery, on the 30th of October, 2017, researchers from the Initiative for Interstellar Studies launched Project Lyra. This initiative aims to evaluate the feasibility of designing a mission to send a spacecraft in pursuit of the interstellar object for close-up study. But can such an ambitious endeavour truly be achieved? Adam Hibbard, an engineer, scientist, and a pivotal member of Project Lyra, as well as the creator of the Optimum Interplanetary Trajectory software, OITS, used for calculating ideal interplanetary routes, believes it is possible. The mission isn't just about uncovering the nature of Oumuamua. It's an opportunity to revolutionize our understanding of the entire interstellar domain. According to Hibbard, the first critical step is to develop a one-of-a-kind probe capable of enduring the extreme conditions of deep space. It must be equipped with robust radiation shielding to survive the relentless cosmic radiation encountered over billions of miles, which could otherwise incapacitate its scientific instruments. Naturally, catching up with Oumuamua is undoubtedly a challenging endeavour. However, space missions have already demonstrated how to achieve extraordinary speeds without relying on massive rocket engines or vast fuel reserves. Engineers working on Project Lyra aim to send a probe on a breathtaking journey by utilising gravitational assists as powerful cosmic slingshots. One of the proposed flight paths involves a complex planetary manoeuvre. The probe would first launch from Earth and travel to Venus, where it would gain its initial speed boost. Afterward, it would return to Earth to harness the planet's gravity for a second acceleration. Following this, the spacecraft would set course for Jupiter, using the gas giant's immense gravitational pull to achieve its final boost toward the interstellar object Oumuamua. To ensure precise navigation, the probe would also be equipped with chemical propulsion systems, allowing for trajectory adjustments and additional thrust at critical moments. In an interstellar pursuit, every mile per second is crucial. This method has already proven successful. Back in 1979, the Voyager 1 and Voyager 2 spacecraft used Jupiter's gravity to achieve significant acceleration en route to Saturn. Engineers today aspire to replicate this maneuver, but this time with the goal of catching up to Oumuamua. Another, even more ambitious concept is the solar Oberth maneuver. In this plan, the probe would first journey to Jupiter, then slow down and use the planet's immense gravity to alter its trajectory, directing it toward the Sun as closely as possible without catastrophic damage. At this extreme proximity, the probe would gain a significant gravitational boost from the Sun and simultaneously fire its chemical engines to break free from the Sun's pull. Afterward, travelling at extraordinary speeds, it would return to Jupiter, leveraging its gravity once more for acceleration before finally setting a course to chase Oumuamua. If successful, the spacecraft could reach speeds of 74,000 miles per hour, or even up to 163,000 miles per hour. This equates to 20 to 45 miles per second, precisely the velocity range required to catch the elusive object, and do so quickly. However, a major challenge lies in the intense heat. Approaching the Sun at such a close range could expose the probe to temperatures of 1,400 degrees Celsius, hot enough to liquefy metal. Fortunately, a proven solution to this issue already exists. The Parker Solar Probe set a groundbreaking record in 2024 by approaching the Sun at a mere 3.7 million miles, an achievement made possible by its innovative carbon foam heat shield capable of withstanding extreme temperatures. A comparable shield is being designed for a future probe aimed at pursuing Oumuamua, with engineers already developing a 3D model of this spacecraft. Scientists have yet to finalize the probe's trajectory, debating between a gravity assist maneuver involving Earth, Venus, and Jupiter, or a daring solar flyby. Alternative, more unconventional propulsion methods are also under consideration. These include laser propulsion, where a powerful ground-based laser accelerates the probe without using fuel, and solar sails, lightweight structures that harness sunlight pressure to steadily propel the spacecraft through space. While these advanced technologies remain largely experimental, they hold the potential to revolutionize fast and efficient interstellar travel. As for the mission to intercept Oumuamua, the launch is tentatively planned for sometime between 2030 and 2033. The most feasible plan, at present, involves a gravitational assist route utilizing Venus, Earth, and Jupiter. If successful, the probe could catch up with the rapidly retreating Oumuamua by the early 2050s, potentially marking humanity's first close encounter with an object from another star system. The effort to pursue Oumuamua also presents an opportunity to investigate the region beyond our solar system and gain insights into the universe from an extrasolar viewpoint, potentially offering humanity numerous advantages, the scientist explains. So far, only 2 objects have crossed the heliopause, the boundary marking the end of the Sun's influence and the start of interstellar space. These are Voyager 1 and Voyager 2. However, their journey beyond the solar system was largely a stroke of luck. The probes, originally designed for planetary exploration, were never intended to travel such vast distances or endure for so long. In contrast, the new probe is being purposefully designed to venture into interstellar space. It will feature cutting-edge instruments capable of collecting critical data about the environment beyond the solar system, data that remains unavailable to us. This probe could not only attempt to catch up with Oumuamua and unravel the mystery of its true nature, but also relay invaluable information about the enigmatic realm of interstellar space. What exactly do scientists hope to discover if the probe successfully reaches Oumuamua? As previously noted, most researchers believe this enigmatic visitor is likely an unusual comet or asteroid. It is thought to be a dense object made of rock and possibly metals, lacking water or ice. Its reddish hue is likely the result of prolonged exposure to cosmic rays over millions of years. After forming a general understanding of Oumuamua's composition, scientists were prompted to explore another equally important question. What kind of journey brought this object into our solar system? The key to unravelling its true nature might lie not only in its composition, but also in its origin. In 2018, astronomers attempted to trace its trajectory backward. Their calculations suggested that about 1 million years ago, it passed by several stars, coming closest to the red dwarf HIP 3757. It's plausible that its interstellar voyage began there, eventually heading directly toward us. Another hypothesis proposes that Oumuamua may have originated in the Vega star system within the Lyra constellation, located roughly 25 light-years away. While astronomers have yet to identify any potentially habitable planets in that region, this doesn't rule out their existence. It's entirely possible that near Vega, a civilization exists that could be linked to the creation of this mysterious object, which has sparked so much intrigue within the scientific community. Oumuamua is now hurtling toward the constellation Pegasus, continuing its mysterious journey through the cosmos. By late 2025, it will arrive at the distant edge of the Kuiper Belt, and by November 2038, just 13 years later, it is expected to cross the heliopause, leaving the Sun's influence behind and officially entering interstellar space. It came out of nowhere and vanished just as swiftly, leaving scientists with far more questions than answers. Despite its brief appearance, it sparked intense interest in the scientific world, and now researchers are more determined than ever to be ready for the next visitor from the far reaches of space. But what about other interstellar objects? Have there been more since Oumuamua? Indeed, we've had additional visitors from beyond the solar system, and the next one is a bit more conventional. Known as the second I object, it was designated 2I, Borisov. A closer look at Borisov revealed a large comet, like coma and tail, spanning almost 14 Earths in width. However, it wasn't visible to the naked eye, as its closest approach to the Sun in 2019 was still beyond Mars's orbit. Borisov was similar in size to Oumuamua, measuring about 0.5 kilometer across. After its nearest encounter with the Sun, it began to disintegrate, which is fairly typical for a comet of its size passing at such a distance. While its composition was somewhat uncommon, it wasn't particularly extraordinary. Additionally, since it passed through the solar system at a greater distance than Oumuamua, the Sun's gravity had less of an effect on its trajectory. All in all, apart from its interstellar classification, Borisov was a relatively unremarkable object. Alright, now switching on to other fascinating interstellar objects that lack the I classification, C 1980e, one initially belonged to the solar system, with an orbital period of 7.1 million years. Its orbit once extended as far as an astonishing 1.17 light-years from the Sun. However, during its last approach in 1980, it came too close to Jupiter. The planet's gravitational pull gave it just enough acceleration to shift it onto a hyperbolic trajectory. As a result, this object will eventually leave the solar system and become an interstellar wanderer in a few million years. Conversely, there are instances where interstellar objects have had their velocities reduced enough by Jupiter's gravity, causing them to become captured and bound to our solar system. Jupiter plays a crucial role in these events, as other planets lack the necessary mass to significantly alter an object's trajectory. A third body beyond the Sun, and the comet itself is required to either speed up or slow down such objects. Examples of potentially captured interstellar comets include Machholz 1 and Hyakutake C 1996b2. These objects stand out due to their highly elliptical orbits and unusual compositions compared to most other comets. This makes them intriguing and promising targets for future exploration, as the solar system may have already done the hard work of capturing interstellar objects and placing them within our reach. One more clue that an object might originate from outside the solar system is if it orbits in a retrograde direction compared to most other objects within the solar system. A notable example of such an object is 514,107 Kayapauka-Awela. What makes this object particularly intriguing is that it's an asteroid, unlike the majority of interstellar objects we typically anticipate encountering. If it were once a comet, the volatile materials might have already burned off, suggesting it was captured very early in the solar system's history. Additionally, its orbit is distinctive, as it is locked in a 1-to-1 orbital resonance with Jupiter. In a nutshell, the mystery of Oumuamua continues to captivate both scientists and the public alike. Its unusual characteristics, such as its unexpected acceleration, bizarre shape, and lack of a typical comet tail, challenge our understanding of space objects. While theories range from natural explanations to the possibility of it being an alien spacecraft, no definitive answer has yet emerged. As future missions, like Project Lyra, aim to explore such interstellar visitors, the quest to uncover the truth about Oumuamua exemplifies humanity's drive to push the boundaries of exploration and knowledge, opening doors to understanding the universe in ways we've never imagined before. And we've come to the end of today's video. Thanks so much for watching. If you found this episode intriguing and valuable, don't forget to like and subscribe to the UFO Universe channel. We're committed to revealing the secrets the world isn't ready to talk about, from alien civilizations to secret space programs. Be part of the journey into the unknown.